Alright guys, welcome to your 26th physics video, and in this video I want to talk to you guys about a couple more physics vocabulary words, specifically work and power, because my guess is that you may have different definitions for work and power than scientists do. So whenever you may talk about work, you might talk about what you did during the day to earn a little extra cash, but physicists say that work is actually equal to force times displacement. Interesting. And you may measure how much work you do by how much your paycheck is, but they actually measure it in a unit called a joule. So they say that 1 joule is equal to a unit of force, in this case 1 Newton, times the unit for displacement they chose is a meter. So if you took an object and you moved it 1 meter with a force of 1 Newton, then that would mean you did 1 joule of work. So let's go ahead and take a look at a real quick, slightly better example. Say that you have a big brick, and that was sitting on the ground, but you decided to lift it up, and you lifted it up, I don't know, 2 meters. Now, how much force was needed to lift this brick up? Well, a force of 5 newtons we calculated. So again, if you lifted a brick up off the ground 2 meters with a force of 5 newtons, then when you multiply those together, you would figure out that you did 10 joules of work. How awesome is that? Now, okay, take a deep breath, Bucky. Concentrate. How awesome is that? Now you can brag not only about how much work you did, but you can also throw some physics into there. So that's what work is. Simple enough. Now let's go ahead and talk about power. Now, scientists say that power is the work done divided by the time it took to do it. So whenever you talk about power, they use P, and of course, work over the time it took to do it, and we symbolize time with a lowercase t, and my t looks a little bit weird, so I'm going to draw that again. T. So power equals work, and we already know what work is, over time. Now, power is actually measured in something called watts. So W-A-T-T-S. Now you hear watts a lot when you're talking about electricity and especially light bulbs. So what exactly is a watt? Well, 1 watt equals a joule, which is the unit they chose for work, and their favorite unit of time is a second. So let's go ahead and take a look at this. And actually, I'm running out of space right here, so I'm going to put it on a new slide. So let's say that, okay, let me just draw a ground right here, and you have a big block this time, and I'm going to say that this block is cheese, because I wish I had a big block of cheese right now. Now, what you did is you got bored one day, so you decided to push this block of cheese. Here's your little arm pushing it. You decided to push this block of cheese, I don't know, let's say that you pushed it a total distance of 16 meters, and I guess we don't even need that. So you push this block of cheese a distance of 16 meters. Why? I don't know. You're kind of weird. You do weird stuff sometimes. Now, how hard was it to push this block of cheese? Well, it was so difficult that you actually used the force of 20 newtons. That is a lot of force. You must have some muscles there. And how long did it take you to move from point A to point B? Well, the block of cheese was like way over here, 16 meters away, but you're pretty quick at moving cheese, so you did it in 8 seconds. So what we want to do now is we want to figure out how much power it takes to move a block of cheese 16 meters when you use a force of 20 newtons and it takes 8 seconds. Well, let's go ahead and think of what we know already. We already know that power equals work over time. However, we do know that work equals force times displacement. So before we can calculate the power, we first need to calculate the work. Now, since we don't have this work right here, because we have distance, force, and seconds, we need to calculate that. So let's just go ahead and substitute this W right here for what work is equal to, in other words, force times displacement. So in other words, power not only equals work over time, but power is also equal to force times displacement over time. It's pretty much the same exact things, except we substitute force times displacement for work. So let's go ahead and figure out that right now. Using this final formula, we can say that the power, what you're trying to figure out, equals force of 20 newtons times displacement, which is how far did you move it, 16 meters, over a total time of 8 seconds. So now if we go ahead and run some calculations, 20 times 16, and I'm going to go ahead and throw out my units right now. Power equals 20 times 16, which is, if I'm correct, 320 over 8 seconds. I'll just go ahead and write 8 right now. So since we used the correct units of Newton, meters, and seconds, we're going to end up with the unit of power, which is watts, and 320 divided by 8 gives you a final power of 40 watts. So, fun fact, whenever you move a brick of cheese with a force of 20 moons and you move a distance of 16 meters and it takes you 8 seconds, you do 40 watts of power. How is this useful? Why would you ever need to calculate this? What is the purpose of this at all? Well, in the next couple tutorials, I'm going to show you guys some useful applications other than, just calculating how hard people work whenever they move cheese. And I'm going to show you guys how to use these formulas in a useful manner. But for now, that's all you guys get. Hopefully you'll understand the concept and the difference between power, work, and all that good stuff. So thank you guys for watching. Don't forget to subscribe, and I'll see you guys in the next video.